Okay, so I hope I am audible, right? Yeah, so good afternoon. So I can see Utkarsh is here. So good afternoon. Yes, Nishant, good afternoon. Okay, so I can see many other students are there. So we are even live on YouTube, so I can see there are many students on our YouTube page. Okay. All right, so I think we should start the session now. Okay. So good afternoon, everyone. I am Shivam Gupta, Senior Innovation Engineer from STEM Robot Technologies, and you are watching our sixth session of our ATL Marathon preparation series. So this is the session where you will be learning about how you can provide and make the submissions, right? Like if you want to make the submission, if you want to do the submissions, so for that you need to prepare yourself, right? You need to make document, you need to prepare the video, and we are providing the necessary information, right? We are providing you the details how you can prepare all these things. Also, with our series, you can learn that how the things can be done. Like if you are working on a prototype, so you can make a prototype on Tinkercad. Now, Tinkercad is a online simulation software where you can make your prototype of any circuit. Now, this is our sixth session, and you have, if you are watching our session, like if you are, okay, just a minute, everyone. Yeah, so if you are watching our sessions, so you have learned about several things, like we have discussed about circuit simulation, how you can make breadboard circuits, how you can make Arduino circuits. And before this session, we have taken two sessions where we have discussed about Arduino. So today also we will be discussing about Arduino. So this would be the third session on our Arduino series. So let's start with our session today. So we have discussed about LEDs, right? We have discussed how you can glue multiple LEDs using the Arduino board. And in the previous session, we have also discussed that how you can glue a 7-segment and how you can make the numbers on 7-segment display. Today, we will be discussing about a very interesting topic, that is PWM, pulse width modulation. And with this topic, you can work on the brightness of LEDs, right? You can work on brightness like the LED, like you can glow the LED in different, you can say, intensities. In fact, not just the sound, not just the intensity of light, but also you can change the value of sound. So before going on to that, let me show you how it actually works. Okay. So here you can see that I'm having this LED and it is connected like this. So students, can you see that this LED is not just blinking, but it is changing its intensity of brightness. Like right now, it is changing its intensity. At one point, it is off, but slowly it is changing its intensity. The brightness is increasing, and when it reaches at its maximum brightness, then what happens is it is reducing its brightness. So you can see here, like we in this activity, we have not just turned on and off an LED, but we are actually controlling its brightness. So like this, you can change the brightness of an LED. Also, you can use a buzzer. Like right now, we are using an LED, but instead of using an LED, you can use a buzzer. And with that, you can see that the sound of the buzzer will be increasing and slowly it will decrease. Then again, it will start increasing, right? So this kind of thing can be done. Now, this thing is not possible with a regular pin block. Like if you have watched our previous sessions, so we have used a block set pin, right? That blue color block. With that, what you can do is you can turn on an LED on or off, right? But you cannot change the brightness of the LED. So for that, we will be using another block. Also, that block has to be used in such a way that we need to add some values. So let me share my screen, and then you will be able to understand that what I'm trying to explain you guys. Okay, so students, I have shared my screen. Okay. So here I have opened the Tinkercad platform. I hope by now you all are aware that how the Tinkercad platform is used, how you can access it, how you can create your account. Okay, so here you can create, after creating your account, you can start using it. And this is the today's activity that I will be explaining you guys. So here what I've done is I have used this Arduino and I have simply connected an LED. So students, if you are new to our channel, if you are watching this session for the first time, don't worry. This is how you can connect an LED. And after this session, you can watch our previous sessions. So we have discussed how you can connect an LED. Even we have discussed about Arduinos, like what is an Arduino, what type of Arduinos are there in the market that are easily accessible, right? And like this, you can connect the Arduino. You can connect the LED using an Arduino. Now, it's really simple to connect an LED. But right now, if you just observe, normally I used to connect an LED to this 13th pin. Although we can connect the LED at any pin, but specifically I have connected it here on pin number 11. So the reason is because if you just notice, if you just pay attention here, so can you see something? Let me just mark it. Okay, so can you just see here? This is digital PWM pin, right? So PWM means pulse width modulation. And if you just pay attention here, this symbol, right? This is a curly line, right? A small curly line. Okay, so this type of symbol is available. Just a minute, guys. Yeah. So this kind of symbol is available to only few of the pins, like pin number 3, 5, then 6, 9, 10, and 11. So these are the PWM pins. So that means all the pins are not PWM pins, only the pins that I have marked, or there is this symbol, right? Those pins are PWM pins. Now, what are these PWM pins? So students, like in our previous activities, in our previous sessions, you have learned how to turn on and off an LED, right? We use a simple block. Like if I just go to the code, so here you can see that we have this type of block, like set pin. Then we need to specify the number, the pin, like 13 to high or low, right? So we used to do like this. Okay, and in case if you want to turn off an LED, so simply we just have to make it low, right? But now if we want to change the brightness, so you know what's happening here. Actually what's happening here is that we are achieving a state. We are getting the like we are trying to achieve a state where the LED is not like LED is between the high and low condition. Okay, what I mean is, okay, let's take an example. So we all watch television, right? We all watch TV, we all watch different movies or series on our television. Now if we want to turn like if we want to increase or decrease the volume, so what do? We just take a remote, we press the button, and then the volume starts increasing. Like if it is 0 and if we just press the plus button, so what happens? The volume increases from 0, 1, 2, 3, 4, and it goes up to 100, right? But there is a state, or what I mean is that there is a series, like from 0 to 100 we are actually able to get any value, any specific value, right? It's not just that we will get 0 or just 100. Okay, so we can get any value between 0 to 100. Similarly, we need that kind of state where we can actually get a value between the minimum and the maximum value. So PWM pins help us in getting that condition or that state. So with the help of these PWM pins, we can actually get any value, or you can say any type of brightness that we want. So students, I will explain you that this thing more like by like with the help of code. Okay, but before that, if the things are clear up till now, so just type yes in the chat, or if you are live through our YouTube channel, so just type yes in the comment box. Okay, that's great. So I'm getting yes. Okay, that's great. So, so here, like we have used these two types of blocks, okay, like set pin 13 to high. But students, if you just notice, if you just see here, we have another block that is set pin. Right now 3 is written, so it's like set pin 3, 2, and here we can type a value, right? And if you just click here, so can you see only few numbers are written. It's not like that all the numbers are written from 0 to 13. And why is that? It's because you can see I have already mentioned here that there are only few pins that are PWM pins. Like 3 is there, then 5, 6, 9, 10, 11, right? All these pins are PWM pins. So that's why only these pins are available here. Now you can select any of these pins, and after selecting, you need to connect your LED to that pin only. Okay. Now let's say right now I have connected my LED to this pin number 11. So I will select pin number 11. Now here we have this blank. So students, in this blank, we need to specify that how much value we need. Okay, like I have given you the example of volume, right? From 0 to 100. So 100 is the maximum value. But here, if we are working on Arduino, so the maximum value is 255. Okay, it's not 100, it's 255. So the value is from 0 to 255. So that means if you are writing 255, so then we will get the maximum, you can say intensity of light. Okay, but if you type 0, so LED will be turned off. Now, if you type any value in between 0 to 255, so by doing that, you will be able to get your desired value, or you can say the value that you want. the brightness that you want. So let's say if you type 100, so based on that value, the LED will glow. If you type 150, so it would be much brighter than the LED that would be glowing at 100. Similarly, if you take 200, so it would be brighter than 150, right? So like this, you can increase or decrease the value. So let's try like how we can do this type of thing. So first I will remove these two blocks because we are not like we do not need these blocks. So here we need this type of block. Okay. Also, I hope that this thing is clear that I have connected my LED to pin number 11. Okay. So here in the code, I have used this thing, set pin 11 to. Now see, first I will show you, like if I take 255, so now what will happen? I will click here on start simulation. Okay, so the LED is glowing. Okay, it's just glowing. Okay, just a minute, let me refresh it. Okay, so it's glowing. Right now the intensity is maximum because we have taken 255, which is the maximum value. Now if I take, let's say 100. Okay, so now the brightness is a little bit lower than the one that we were getting at 255. Although it is not, maybe it is not visible at this point, but if you are using a real Arduino, like the way I am using, okay, so by that you will be able to get the value. Okay, the brightness, I mean, fine. So similarly, if you type 0 here, okay, so you can see the LED will not glow. Okay, so I have, okay, so there's a doubt. Okay, the value of resistor, it's 220 ohms. Okay, it's 220 ohms. So like this, we can change the value, and by that you can increase or decrease the intensity. Now to make a transition, like you guys have seen in Diwali lights, like what happens, there is a small LED, it first it starts from like the LED is off, then slowly the brightness of that LED increases and it reaches to the maximum value, and then slowly it reduces and then again it turns off, right? So you can even make this kind of transition, you can make this kind of the brightness, like you can change the brightness. Okay, for doing that, what you need to do is you need to make a combination. So let me show you like how you can do it. So here, if you see, so first I have taken this block that says set pin 11 to 0. Then I have added a wait. Like we have just selected the seconds, right? Like 1 second. We can even use 1 millisecond, or not even just 1 millisecond, but we can type any value that we want. So if I am writing 1000 milliseconds, so that means it is 1 second. Okay. So now try to understand, if we are writing 1000 milliseconds, so that is 1 second. But if I am writing, let's say 500 milliseconds, so can anyone tell me that how much, like what is the value in seconds that we will be getting? Like 500 milliseconds, how many seconds is that? Okay, very nice. That's good. Yes, that's correct. So 0.5 seconds you can say, or half second. That's correct. Very good. Okay, so similarly, if I am writing 100 milliseconds, so that would be 1/10 of a second. Okay, so by doing that, we can actually provide a delay, right? Or we can, like you can say, you can stop the circuit for not just stop, but actually wait. You can make the circuit wait for 1/10 of a second, right? So like this, you can change the values of this delay. Now, if I duplicate this, so what happens is now we have another set. And here, if you just change the value, like right now, what we are trying to do is like from 0, its value will increase, right? So first, let's take 0, and slowly we will increase the value. So you can take, let's say 10. Okay, so here we have 10, and we will take this this weight block like this only. Okay, then students, you can duplicate it. Okay, because right now we need a lot of different blocks. Different as in, like first we need a value that is 0, then slowly we will increase it, that is 10. Then you can take it as let's say you can take 25, doesn't matter. Okay, then you can take 50. Similarly, we will increase it. Okay, so I have duplicated the blocks. Okay, just okay. So from 25, then we have 50. Then you can take let's take 80, then 100. So our target is to reach till 255. And the reason why I'm taking small values is because when the when the voltage will be increasing, right? Like yeah, so like when the value will be increasing, like from 0, 20, then like 50. Okay, so slowly we can see that the like the brightness is changing. Okay, so we will be able to see that. So like this, I have taken 150. Let me duplicate it. Okay, so you can change the values, and these values are not fixed, or like these are some compulsory values that you need to write, right? It's not like that. You can take any value that you want. Here I have written 180. If you want, you can write 185. You can even write 190. So it doesn't matter. So like this 220, and okay, let's finish it up here. So like 255. Okay, now I'll just remove this part. Okay, so here we have written several, like we have added several blocks. Here we have several blocks, and now let's try that. At least let's see what we have made. So here I will click on start simulation. And you can see, if I just zoom in, so you can see like first the LED is 0. Okay, let's do one thing. Let's add, let's increase the value. Like let's take 1000 milliseconds or 1 second. So you will be able to see that now when the maximum value is reached, again the loop or the code starts running, and we can see this entire like this thing that works again. Okay, so it starts from 0, then slowly its value increases. And right now we have taken these number of blocks. If you add more blocks, like let's say if you want to see a smooth transition, so you know what you can do. Like you can take small values like 0, 5, 10, 15, 20, 25, 30, and till 255. I understand it would take a lot of blocks and time as well, but then you can see the transition would be very much smooth. Okay, like right now, if you just see here, there would be some like you can say lag or delay as like you can see, right? But if you take small values, the more smaller values you will take, the smooth transition it will get. Okay, you will see a smooth transition. So that even that's why I have taken like small values like 0, 10, 25. Otherwise, I could have taken 0, 50, 100, 150, 200, 255, right? But to make this look smooth, I've taken many values. And similarly, now you have reached the maximum value, that is 255. Now, if you want to get back to 0, so you know what you can do? You can take all these blocks and then you can write down the values in a descending order. Like you can take 255, then 220, then 180, right? Then 150. Similarly, like this only. Okay, you can add it. So let's try to do this thing as well. So right now what I'm doing is I will duplicate this entire set. Okay, and then what I'll do is let me first join it. Okay. So here we have given 1000 milliseconds. So by this we can understand that the blocks that are used before this one are used for like increasing the value from 0 to maximum. Now after this block, right, where we have written 1000, all the blocks that we will be using are for reducing the value from maximum, that is 255, to 0. So let's try this. Okay, so here we have 255. So now what we can do is we can use the same values like 220, or even you can change the values, doesn't matter. Like let me show you here, I have taken 200. I will take 190. Okay, so it doesn't matter, whatever value you take, it will work. So I'm just changing the values like 120, 100, then 80, then 60, then 30. Okay, so we have several other blocks. Okay, so let's take 20, 10, 5, and finally 0. Okay, so like this we have like added the blocks. So now what will happen is from 0 to 255 and from 255 to 0. Okay, so now let's see how does it looks. Okay, so you can see here, like it starts from 0, then maximum value, then slowly it comes down and it's 0. Okay, so this thing that I have explained you today, it's just for a single LED. But if you want to glow, like if you want to make a combination of several LEDs, so you can do this, right? You can like, as I've already mentioned, here we have several PWM pins. Like right now, I'm just using pin number 11. You can use pin number 10, 9, 6, 5, 3, right? So we have these PWM pins. You can use them and you can do this kind of like brightness control. So students, any doubt, anything that is not clear in this concept? You can type it in the chat if you have a doubt. Okay, that's great. So there is no doubt.
No, sir, no doubt.
No, sir. Hello.
Okay, fine.
No,
So
sir.
that's great.
No, sir. Okay, sir.
There's no doubt. Okay, so students, like you have seen that how I like how this block block combination can be created, and also like you have seen that I have shown you the entire thing using the Arduino as well, right? Now how you can do this, because we are using the simulator, but in case if you are if you want to do all these things using the real Arduino, so how is this possible? So it's very simple. So let me show you. Okay, so I have shared my screen. Okay, and you can see that this is the Arduino IDE. It's the software through which you can type the code, and you can, after typing, you can upload the code in your Arduino, and then the code will run, and whatever sensors you have connected through this Arduino, they will work. Now, if you are not like comfortable with the textual coding, right? So, and you are comfortable with this Tinkercad platform, so it would be really easy for you to even use the Arduino IDE and even use a real Arduino. All you need to do is, after creating your code, like you have like the way I have made this code, you also need to do the similar thing, right? Then what you need to do is, here we have the option. Okay, just a minute. Okay, let me refresh it. Okay, so students, now like after creating the um, code like this, all you need to do is, here we have the option download code. Okay, so just click on it, and then what will happen is the code file will be downloaded. Okay, now you can go to the place where you will find the downloaded files, and you just need to click on it. So just a minute, it's opening. Okay, just a minute. Okay, so I hope you have seen, like I have clicked here on download code option. Okay, this one. After downloading, you will get a file like this one. Okay, so you can see that whatever blocks you have used, now they are converted into text, right? Text-based code. Like you can see here, like earlier we have used 0 as our initial value, then 10, then 25, then 50, 80, 100, 120, and it goes till 25. And after that, the series was in decreasing order, so it was like 220, 190, 150, and it goes till 0. Okay, so this entire block based code is now converted into text based code. Now you can upload this code in your Arduino. Okay, I will also explain that like from where you can download this Arduino software, right? Because if you want to work on the text based platform, right, so you need to use this platform. This is the coding platform for Arduino. So don't worry, I will also show you guys that from where you can download it. Okay, but before that, let me show you, like, we need to specify that which board we are using. Like students, if you see here, there are so many Arduino boards that are available. Okay, you can see there are so many different boards, and right now we are using Arduino Uno. So it's already selected. Okay, then we need to set the port. So like this, we need to select the port. Now there are two things, that is a verify icon and upload icon. So if you click on verify, so what will happen is the code will be like, we will verify that in case if there is an error, maybe if anything is wrong, so it will check. Although this code is converted directly from blocks, so definitely it would not have any error. Okay, but if you are writing your own code, so then you need to verify it. Like let's say I will remove this bracket. Now if I click here on verify, so just see this bar. Okay, so it has turned orange, and also it will show that here we have an error. But now if I just add this bracket back, and if I just click here on verify, so now you can see that here it is written as done compiling. Okay, and there is no error. Fine. So now after verifying, we just have to upload it. So just click on this upload icon. Now the code will be uploaded. Okay, now the code is uploaded, and you can see here so by this we can actually perform this activity using the real Arduino as well. Okay, so students, I'll do one more thing. I will be using a buzzer. Like right now I have a buzzer. Okay, let's try to add this buzzer instead of this LED. So if you just see the buzzer, so here you can see the buzzer is having two legs. Okay, so I think it's not visible. So no problem. Like right now, if you see here, the buzzer is having two legs. Okay, one is this one, another one is this one. Okay, now it is used in a similar way like the LED is used. Okay, now I guess it is visible, right? Like if you just see here, one of the leg, like the one which is on this side. Okay, this one. So it is bigger in size as compared to this one. So you can use it in this way only. Like the positive is for, like what I'm doing is, okay, so students, as you have seen, that okay, you can use a buzzer and you can change the value. Okay, you can change the intensity. So not just the brightness, but the sound as well, right? You can change the value of sound. And here you can see that we have used this like block-based platform with a real Arduino as well. Okay, so also I will show you guys like from where you can install the software of this Arduino. So I'm just sharing my screen. Okay, so I have shared my screen. You can see, you just need to type Arduino. Okay, and here you will get this option, software. So just click on it. And scroll down a bit. So you will see that there are several options like Windows 7 and newer. Okay, zip file. You can even get it from Microsoft Store, right? Even it is for Linux as well. So you can install any of the that from like you can use this one like Windows 7 and newer. So just click on it. Then you need to click here on just download, and it will start downloading. Okay, so like this you can download the software. After the file will be downloaded, you can easily install it. So like this you can have the Arduino IDE platform, and the platform after downloading will look something like this. Like after downloading and after the installation part, if you open the software, so it will look like this, where you can type your code and then you can try to run it. Okay, so students, any doubt that you guys if you are having? You can type it in the chat. Okay, so yes, if you have a doubt, you can type it in the chat. If you are live through YouTube, so you can type it in the live chat. Okay, so we will answer it as well. Okay, so how can we download the software? So as I've mentioned that you can just go on to the Google. You just need to type Arduino. Okay, then we have the software option. Click on it, and then you need to specify. You need to see that which system you are using. Like if you are using a Windows, like if you are a Windows user, okay, so you will select this one, Windows 7 and newer. Okay, so you can just click on it and then you can start using it. Okay, the file will be downloaded. So after the file gets downloaded, you can click on it. You need to install it. Installation is very simple. Okay, and then you can use it. Okay, so students, So now you guys must be thinking that we are taking these sessions, right? We are working on Tinkercad. Like now it is the 6th session that we are working on Tinkercad platform. And why are we focusing on this platform so much? So let me show you something. So like you have seen this Arduino and the components that we are using, right? You can easily do the coding because by using the blocks, you can easily join them and you can write down or you can form the code. But apart from all these things, now we are actually focusing on the submission part, right? If you want to make a document, so what all things can you add in that document? So things like you can take the screenshot, you can take the screenshot of the circuit, you can add that one, right? You can add the components that you are using, you can add the schematic. Now let me show you this thing. Like on the right side, right top corner, you can see this thing, circuit view. But if you click here on schematic view, so you can see here, let me just zoom in. Okay, so this is the schematic. Although let me show you this in another example. It would be much more interesting. So students, this is an example of a calculator. Now let's say you are making a calculator for a project, okay? For let's say for any project or for any competition. So here, after designing your circuit, if you click here on this schematic, so you can see that here we have the schematic. So right now you guys are in school, so I can understand that you won't be able to understand about this schematic, but as I'm an electronics engineer, so in electronics this schematic is of great importance. Like if you want to make any project, if you want to make any let's say device, so schematic is very important. So even you can add a schematic in your submission as well. Okay, apart from that, if you click here on this component list, so you can see that you will get the list of the components that you have used. Okay, because see, there are so many components that are there in the market. Now how you can know the exact name of each and every component, right? Like let's say you want to make a project based on a gas sensor, so there are so many gas sensors, like MQ sensor is there, right? Now the series, like the MQ series is really you can say a vast series. There are MQ3, MQ4, MQ135, right? There are so many sensors. Now how you will get the exact sensor, or how will you get the information or the name of that exact sensor? So whatever sensor you have used in this project, you can see the name. Like let's say for this calculator, here we have used the LCD. So students are only aware that that is like the LCD they have used is an LCD module. That's it. But students are not aware that which LCD they have used. So here you can see that it is LCD 16:2. If they have used a keypad, so it is 4:4. If they have used a resistor, so it is 220 ohms resistor. So you will even get the details of the component that you are using. Okay, so I hope you have seen this project before. Like I have discussed about this project in our previous sessions. If not, let me show you. So this is a calculator. Okay, this is the Arduino, as we are working on this Arduino since last 2 sessions, right? And this is a display, or you can say an LCD, liquid crystal display. This is a keypad module. Now whatever keys you press, you will be able to get the number on this display. Now here we have these alphabets A, B, C, D. So in the code we have mapped them in such a way that A means plus, B means minus, C means multiplication, and D means division. Then this star means clear, clear screen, and this hash means equals to. So like if we are using, if we type any number, let's say 12, then we need to add, let's say 8. Okay, so definitely the answer should be 20. So if I click here on this hash sign, so you can see the answer is 20. Okay, so similarly, if you type 9 into 5, so answer should be 45. And you can see the answer is 45. So students, you can see that the projects, the activities that we have discussed in our previous 3 sessions, they are the activities that will help you to understand the concepts. But you can work on so many activities, so many projects using this platform. Okay, there are so many sensors that you can use, that you can interface with the Arduino, and with that you can make your project. You can make the prototype of your project, and then with the tools, with all the things that are available here, you can present all these things in your document. In fact, for the screenshot as well, we have this thing, like if you just click on send to, okay, let me show it again, this thing, send to. If you click on it, so here we have this option, picture of your design. So if I click on it, so the image will be downloaded. So you can see this image has been downloaded. Okay, so whatever circuit you will design, you can download the image. So it is a good thing, right? Because now you are getting a white plain background. Now whatever presentation you will be making, it will also have a white plain background. So your submission, your document will really look neat if you do it in this way. Fine. So students, okay, so okay, that's a good question. So Aryavir is asking that, sir, you used the code you used in the circuit of light bulb of Arduino, right? How it is used for the buzzer too. So see, basically that code is not meant for the LED. Okay, specifically it was not meant for the LED. You can use that code in any of the sensor, right? Like you can use it for like LED we are already using. You can use it for buzzer. You can even use this code for RGB as well. Okay, so you can try this code with other output devices. It will work fine. You can even use it with the laser module, like the laser light. Okay, so even we have a laser light module that you can control using an Arduino. So you can use this code with the laser module as well. Okay, so this code was not meant specifically for LED, but it is it's just a code where we are actually changing the values. Okay, so I hope the doubt is clear. Okay, so students, if you have any other doubt, you can type it in the chat. Okay, so like see projects, yeah. So basically, like we are working on ATL Marathon projects, right? You are working on, like you are working for the project submission. ATL Marathon is going on. The last date is 10th of April. So before that, you need to submit your idea, like the prototype of your project. Okay, so once the project is completed, in case if you just completed, so you need to submit it to the aims, like to the aim.gov.in. So if you just go on to this website, you will get all the details, like from where you can access the submission link, right? From there you can get the submission link, then you can fill up the entire form, and then you can do the submission. Okay, so use the website aim.gov.in. Okay, so students, any other doubt? Okay, so I think there is no doubt. So students, so well, this was our final session of our Arduino series. Okay, so if you want to learn more about Arduino, if you want to work on more projects similar to this one, so you can visit our Tinker Learning website. Okay, and there you can learn that how you can work on several other projects. So let me quickly demonstrate. So just a minute. Okay, so this is our Tinker Learning. Like if you just type here tinkerlearning.com, so you will be able to see this is our website, that is tinkerlearning.com. Okay, so you need to click on this link. Okay, so you need to create your account. Okay, it's very simple. Let me just log out. So students, if you are a new user, so you can see here on the right top corner, you will get this option to register yourself. Okay, so just click on it, and then here you will get two options. On the left, we have a login portion where you can just enter your username and password and just click on login. If you are a new user, so you need to register yourself. So click here on register an account. Just fill up your like details, name, email ID, class. That's it. Okay. So these kind of details are there. You need to fill them, and you will be able to create your account. So I'm already having my account. So I will just click on login. So students, based on your classes, you will be getting the courses. Okay, so there are courses for different classes. So let's say you are in class 8. So you will get the course for class 8. And here we have so many topics that you can work on. Like here we have the topic of breadboard. Okay, so we have worked on several activities based on breadboard. There are few other activities that you can explore. Okay, like LED brightness control using the breadboard. So you can even try this one. Then MIT App Inventor is there, where you can learn how to develop, how to make your own app, and that app will also work in your mobile phone. Okay, then 3D designing is there. Then here we have Arduino. So there are several activities, okay, that you can explore. And this platform is absolutely free, so you don't need to pay anything. Okay, like servo motor control. This activity we have not performed, but you can explore. It's really very interesting activity. So here you will learn that how a servo motor, like what is a servo motor, how you can control it. Okay, then LDR. Now LDR is a light dependent resistor where you can make an automatic street light. Okay, like during the night the lamp will turn on automatically, and during the daytime it will turn off. Okay, so like this you can learn all these things. And finally here we have Python and artificial intelligence. So there are so many things that you can explore. It's really very interesting thing, and everything is free. You don't need to pay anything. So you can register, and after that you can explore. So students, if you have any doubt regarding any of the thing, you can type it in the chat. Okay, type yes in the chat if the things are clear. That's how I will come to know that you all are able to understand. Okay, that's great. I'm getting a lot of yes. That's great. Okay, very nice. So fine. So students, so well, that's all for today. I hope you enjoyed the session and you will try the things that I have explained you guys today. Okay. So keep learning and keep tinkering. So bye bye everyone and have a nice day.